Right. Okay, here we go.
Exactly. Thank you. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Jenny List.
This is episode 318, DIY record lathe, 360-degree LiDAR, and 3D printing innovation lives. This week, one of the funnier news pieces we ran in Hackaday this week, China hosts robot marathon, I guess it was just a half marathon in Beijing. They actually ran it at the same time they ran a human half marathon. And I love Al's commentary here. You don't have to worry about the robot uprising just yet. They started with 21 robots and only 6 made the finish line. And they were, their time was actually really, really bad by human standards. But that's not the point here. The point here is this is one of those like goofy challenges that you do to, show off how your robots are doing, refine them. It's like a brilliant stress test to see how well they do. And, the fact that 6 of them finished it all is pretty awesome. If you watch the video, like some of the ones that finished are being basically, carried across the finish line is too much. But this one has a handle on the back of it and there's a guy walking along with it the whole way. So, but still, what is that? 15 miles, 21 kilometers? That's a good distance to go for a humanoid two-legged robot, even with battery changes. So I think it's awesome. And I think a lot of people in the comments kind of misunderstood this as being, they're coming to take our jobs moment, when instead this is really just a, hey, let's see what we could do with our robots type thing.
I can see that in years to come, it will become like robot football or the electric car racing challenge and stuff like that. It will be the kind of thing that students compete to produce robots that are ever better in, and it will become very competitive, and they probably will become quite good. We'll still turn up to see the Olympic marathon runners. One thing amused me slightly, the sight of robots basically dressed in running clothes with like a gym singlet kind of thing. It's a robot. Yeah. You don't have to give it clothes.
No, some of them had jogging shoes on too, which I guess helps, of course. What's better for padding and doing all the shock absorption than actual human running shoes?
No, that makes sense.
But actually, I noticed that one of them they stuffed into running shoes after the race was over, so that he could do his victory lap or whatever his time in front of the press in running shoes, where it actually ran in kind of just little socks to keep the grit out of the metal feet. Yeah. But no, your call about robot football or robot soccer, RoboCup, robot soccer, robot football is dead on. I mean, that's also just for fun, right? It's just, here's an arbitrary activity you can do that's kind of difficult and gives you something fun to do. And I think that's a great, lots of learning comes out that way.
I should have gone peak British and called it footy.
And then don't forget the Hackaday Pet Hacks contest is underway. We're in week 1 now. Actually, when we're done with this podcast recording, I will go see what kind of entries people have put in the last week. 5 more weeks left. If you have a pet-related hack, head on over to Hackaday.io, make yourself a page, pull down the little drop-down thing to enter it in the contest, and you're in. That's how easy it is.
I don't know if it's appropriate to say this, but I find it a shame there is no category for the biggest scratch inflicted by an annoyed cat when somebody attempts to apply a hack.
Well, and in record time, then on to What's That Sound?
This is a journey into sound.
What's that sound?
What's that sound?
This week is a Reveal the Sound week. We actually got the sound sent in by Space Ben. Neither Al nor I particularly knew what it was. I even saw the video and I'm not 100% sure. We have 3 convincing correct answers, so I'm going to read them to you and you can decide which one you think is probably right. Anyway, until then, Jenny, you've got to give it a listen and guess.
I would say something like a printing press, but probably not.
Well, that's not bad. That's not bad.
It's definitely that sort of repetitive machine.
Yep.
Actually, there would be more noises if it were a printing press. So maybe it's something like an embosser or a hole punch or something like that. But maybe I'm completely on a wrong completely on a tangent.
I heard it, and I definitely heard like a clicking solenoid noise in there. I'm pretty sure. But I'll throw the link for the video in the show notes. It's a video taken from the Inspiration 4 rocket mission. This is the one where they flew up over the polar orbit, and apparently it's some thruster rockets firing. And I think it's a valve opening. And why it's periodic like that, I don't know. But I was actually coincidentally watching another NASA video with some of the thrusters they used on Ingenuity, and they're like that too. They go brat, basically. They fire really quickly, and it's because they use this hypergolic fuel that just wants to explode. And so they just basically jet some in, and then it goes bang, and then they jet some more in, and it goes bang. I think it's the sound of the valves letting this stuff in. Our good answers include from Yekel. We got 3 correct answers. From Yekel, sound of Draco, hypergolic attitude thruster from the Dragon spaceships, probably their solenoids rapidly opening and closing. Man, we're on the same page here. We got, I feel the need for speed, so I fire my Draco thrusters. It is the sound of Inspiration 4, Dragon Resilience firing its Draco thrusters during a phasing burn. Okay, as good as I know. That was from I Can See the Sounds. And from Bulza, we have, those are the engines of the Dragon spacecraft pulsating to change orbit. They pulsate them because they cannot have them 100% duty cycle, so they have them at 50%, and they select the contrary engine, so the sound are actually the valves opening and closing. Damn.
I am deeply impressed. I would never have got those in a million years. I am not worthy.
Well, if you just saw the video that week, which I think a lot
Fair
of people did, you would have noticed this.
Yeah, it could be that I might just have missed the video.
And what's particularly awesome about it is that like one of the astronauts is sitting there tapping on his leg during this whole thing, because it was just like tick tock, and he's going tap, tap, tap along with it. And one of the other astronauts catches him. It's pretty funny. I'll put the video in the links. So yeah, 3 correct answers. I'm going to do something really silly. I couldn't find a 6-sided die, but I do have a Rubik's Cube.
Impressive.
So let's see. So Yeki, you're going to get white and orange. I Can See the Sounds. You get green and yellow, and red and blue go to Bulza. Here we go. I'm going to drop it on the floor because you can't roll it on my desk. Red, that is Bulza. Congratulations. And that was definitely the most informative answer as well. So
They do say that the pictures are better on the radio.
did you hear me rolling a Rubik's Cube?
Yeah,
on the floor?
I heard you roll the Rubik's Cube, but just I had to imagine the colours.
yeah, right? Yeah. Well, congratulations, Bulza. I'll be getting you an email and getting you a Hagaday podcast t-shirt. Those of the rest of you out there, if you are due a Hagaday podcast t-shirt, I'll be getting in touch with you. We had a snafu with sending them out, and I'm ironing that out. I'm actually going to send out a blanket email to everyone who's ever won one, and we'll make sure everyone gets one. Sorry about the delay, folks. Well, that brings us to the hacks, and I wanted to start off with another non-planar 3D printing hack from Joshua Bird. This one, non-planar slicing, is for the birds. Boo title. But yay hack. This one is phenomenal. Let's see, if you weren't following along, about 3 months ago, I guess, Josh gave us this Core R Theta 3D printer, which was very weird. So it's got a vertical axis that's pretty normal. Cantilevered off that, it's got an x-axis. At the end of that, it has another rotational axis that can kind of rotate up and down. And then the build plate itself spins. So it's a set of motions that you are not used to in a 3D printer. Extraordinarily non-Cartesian, I would say. But this is finally the purpose of all of that foolery. I guess there was one more little improvement on the printer here. The pivot on the end of the cantilevered arm didn't turn up high enough, so he couldn't print fully upside down with it. And so he re-engineered that part so that now it can print fully upside down. But the real story in this week's installment is that he got the software running to do the slicing for this thing. And it is phenomenally crazy. it basically allows him to print upside down. And the demo here is a Benchy printed completely upside down on its smokestack. And it's a really crazy pattern that it prints it in, but it's actually very nicely explained in the video and isn't horribly complicated how Joshua figured out the slicing for this. And what's really cool about it is that it's all done as a kind of pre-processing and post-processing step with a normal slicer in the middle. And so what Joshua did was write a Python script that kind of unfolds your object so that it doesn't have any overhangs, keeps track of these rotations. Then you pass it to your regular slicer, which then slices it, and then you just refold it back into its original shape and then print that. And so what happens is the normally kind of level layers get all rewarped as they go. But because he keeps track of the distance of each of the points to the base of the print, he can actually do it in kind of, quote, layers, even though they're these like all twisted, warped up layers. And it makes for a really neat video. If you want to see a 3D printer printing in a way you've never seen one before, you should absolutely go watch the video. And I think it's just really cool that he got this working well enough that it can run on a kind of normal computer. It does the warping and unwarping with an optimization routine. So it's got, and because it has to figure out what order to print the points in by their distance to the floor, not their height. Like normally you print a 3D print, you go Z level 1, Z level 2, Z level 3. But here, because it's going to get unrolled, what's the highest in the print isn't necessarily the last layer you want to print. Because, for instance, in this Benchy example, the bow of the boat kind of folds over. You can think of it like an umbrella or something. You'd want to print the rim of the umbrella at the very end. And so he does a lot of calculation from every point back down to the floor and then unfolds it and then refolds it. It's really, anyway. It's a phenomenally clever idea. I guess he got it from another slicer called S3, and then he calls his simple S3 slicer, so his is S to the 4th power, which is kind of funny too. If you are at all interested in the kind of cutting edge / weirdness of 3D printing, you absolutely need to check this project out.
I have to say I love these type of articles because even though I know I'm probably not going to be plumbing the far reaches of 3D printing in the way they are, seeing what is coming down the line is always fascinating. I think everybody who 3D prints anything remotely mechanical has at some point has to do a print at some crazy angle just to line up the layers in the axis where they're being weakest doesn't matter. And the idea of being able to kiss goodbye to that is very attractive indeed.
Yeah, so he starts off with a functional piece that's actually, a piece of his 3D printer that has these extreme overhangs. And he says exactly that. What's neat about this is that the layers don't end up being along any particular axis. They just end up being kind of however it had to unfold because of its geometry. And I can see that as both a strength and a weakness. Like sometimes you want to use the fact that a solid long noodle of plastic is hard to break. You want to use that to your advantage. Whereas this doesn't have an obvious grain in it, at least a priori. Like you'd have to think about how it unfolds, how the geometry unfolds first and then refolds to figure out where the 3D printer grain is going to be. I mean, on one hand, you don't have to worry about support, so it makes that whole part of things tremendously easy. On the other, you don't necessarily know where your grain's going to end up, where the layer lines are going to end up. But on yet a third hand, I guess, they get kind of wound up in each other and twisted in each other enough that it may not matter so much. And I think that's really cool.
There was another piece this week involving non-planar infill, which used less expensive trickery to just do the wavy non-planar stuff in the infill. You could do it with a normal 3D printer. Definitely, I'm looking forward to seeing that kind of strength enhancement.
Yeah, I love that one. I'm glad you picked that up. I was going to riff a little bit on non-planar printing in general, too. I'll throw 2 links in for you in addition to this one Jenny just mentioned. One is a reasonably old article now by Moritz Walter, 3D printing non-planar layer FDM. And this is from way back in 2016 when this idea was kind of brand new. He kicked the tires on a bunch of different non-planar methods. And then another attempt at doing a non-planar slicer, a universal non-planar slicer for 3D printing is worth thinking about. And both of these articles kind of make the point that the slicer here is the hard part. And Joshua Bird's version here is really neat because it uses this non-planar unfolding technique to completely get rid of supports. What's fun is there are other takes on non-planar printing. And so, for instance, in Moritz Walter's one that I just mentioned, he's using non-planar 3D printing because he wants to print airfoils, for instance. And so he wants a rounded surface to be smooth. And there you have a totally different goal. And so the slicing you do for that has to be different from the way Joshua does it. And this other one, a universal non-planar slicer, is also doing kind of what you mentioned in the non-planar infill one. It's just throwing waves in there to make things stronger, not necessarily to undo supports. And so what's fun here is that all of these are different approaches and really different approaches to solving really different problems by going non-planar. And I think that's really cool too. Like some people in the comments on Joshua's thought, this solves this problem but doesn't solve that problem. And yeah, that's exactly right. This is this is not the solution to everything. And you certainly won't want to use this if you need to know where the grain is. If your project is basically square and you just want to make it stronger, then you want to do something like this wavy infill. If you have something that needs a smooth exterior surface and you want to use the non-planar aspect of it to cover like a rounded smooth surface, like on the wings, like on the airfoil wing example. Like there are all sorts of really cool different niche uses for non-planar printing, and I don't think any of them are the same. And what I think is fun about this is that a lot of these machines, but in particular Joshua's here, are nimble enough that they can do a lot of different non-planar moves and can be used for this purpose or that purpose. And it's up to you to pick the right funny non-planar slicer to implement what you want to do. And I think there's room for even more innovation here. And I just, right when you think 3D printing is settled and, Bamboo Labs has come in and turned the last little screws on the refinement of it, you get people coming in with really clever, just, out of the box ideas like this that, are just in a totally different world. But I will admit that seeing this slicer finally working really makes me want to build one of Joshua's crazy printers. I mean, it's the weirdest mechanism I've ever seen because, the plate rotates and then it goes up and down and in and out and then it rotates the head. I mean, it's crazy. It's got too many degrees of freedom. None of them are right. It's lovely. It's the least Cartesian thing I've ever seen. And now that I see it working and now that I see, what he can get it to do with not very difficult software application. I mean, it's a lot of optimization time. So your computer has to crunch numbers. But the human load is extraordinarily light. And I think that's awesome. Really makes me want to try one.
There was a time a few years ago when almost every hackerspace seemed to have somebody's unfinished Delta printer project that never quite worked.
Yeah, right.
And I wonder if this will be the new Delta printer. Every hackerspace will have one of these that somebody's building and can never get quite right.
I kind of want to say I hope so, but I kind of hope they get them all right too.
It'll be awesome to see. But you know how it is.
As long as some of them are gotten right, I'll be happy.
Yeah, and definitely every project I've ever brought into a hackerspace has completely worked and never sat around for a very long time. I promise.
Certainly. I have never left any toxic waste in a hackerspace and then fled the country.
Yes. My first hack comes from Ronald, and it's a record cutting lathe. Now, this isn't just a record cutting lathe, this is a particularly good record cutting lathe. It's actually surprisingly easy to make a record cutting lathe. All you need is a turntable, which can spin round, a piece of relatively soft plastic to stick on top of it, and a needle that you can waggle around with some form of loudspeaker or other way of making it move. I fully admit that I've experimented this when I was much younger. My BSR jockey wheel mains powered turntable and rather nasty 1970s amplifier and doctored speaker, it made a sound that could be played back, but it was not what you would describe as hi-fi. But Ronald has really gone to town on this project. It's a CNC type project. It's a gantry that moves across, very similar to a single-sided 3D printer. His cutting head, he's put an enormous amount of work into it. He's actually implemented stereo as effectively as possible. There are a pair of drivers. It says tweeters, but I suspect that the actual bit that makes the sort of diaphragm side that tries to make sound vibrate will have been removed to connect it direct to the needle. But to be able to record the stereo sound into the groove requires quite some precision, and he's put an enormous amount of work into doing this. One of the things I was particularly interested in, his turntable. It's actually a difficult thing to find a turntable for this because obviously it needs quite some strength. You can't just use some belt drive turntable that takes almost no power, just like the kind of thing you'd play the records with. He's used the legendary DJ turntable, the Technics SL1200. I believe these are still the turntable to have, but certainly when I was much younger, they were definitely the turntable to have. You couldn't be seen as a DJ unless you turned up with a pair of Technics. But if you ever have taken one of those apart, which I have from time to time, repairs and stuff like that, you'll find, in effect, there's a very, very hefty multipole stepper motor underneath. Those things have some serious torque. My guess is that it's got enough that it can drag around a plastic that's being held back by a needle with quite significant tracking force to machine out the groove. He tried polycarbonate. I wasn't surprised when it said he didn't find it suitable. Polycarbonate is actually quite tough stuff. It's what we used to use back in the day for some of Smidsy the robot's armour. It's that tough. But he ended up with commercially available vinyl blanks. I have to say, I didn't know that commercially available vinyl blanks were a thing. I would have loved to have known that 30 years ago when I was a student and trying to do this. But then again, I wouldn't have had the money to buy them. I just thought this was a really cool project, and I secretly want one myself, but I recognise I will probably never have one.
Yeah, absolutely incredible that he managed to get stereo working on this. And really, go listen to the samples. It sounds pretty darn good.
Yeah, definitely.
Kudos all over the place. That's absolutely fantastic. I love the kind of 3D printed aluminum extrusion gantry and the whole thing going on there, though. It's like a 3D printer / CNC machine gone wild with this crazy audio cutting head on it. And of course, that's exactly what it is. So, kudos for making this thing.
It's certainly much higher quality than the Teenage Engineering record cutter that was available a while back. I always kind of wanted one of those, but thought it was far too expensive. But now I've seen this, I'm ruined for the Teenage Engineering one.
Yeah, that was just a toy.
Basically, yes.
Not to be offensive. Well, speaking of hacks to add to your to-do list, here comes Laserborg's Pi LiDAR, a Pi-based LiDAR scanner. And this is just a fantastically cool project. I didn't know that you could get LiDAR scanners these days, little, spinny scanning ones that scan in a complete 360-degree circle with such high resolution for under $90, but you can. And that's what Laserborg uses here. He couples that with a Raspberry Pi high-res sensor and a fisheye lens and mounts it all on kind of a flat rectangular tower. What's cool about that is that the LiDAR is in the vertical plane, and so it's kind of scanning what you might think of as the longitudes of a globe as this thing spins around. And on the other side, the fisheye lens is taking pictures, and so it gets a spherical image as well. The whole thing sits on a servo motor, so it can spin around. So the LiDAR then kind of images the longitude lines of a globe while the fisheye camera is taking pictures. Some software on the back end stitches these all together, and the result is a 360-degree LiDAR point cloud that has accompanying photographic images along with it. And so that lets him do things like colorize the pixels of the point. So you can actually have a 360-degree spherical space mapped out with all the distances and the colors of the points. Or you can do like, color based on the distance from the observer or whatever. The machine here is fantastic. It's a nice 3D print. It actually has a 3D printed slot in it for a power bank, which runs the whole show. And you put it on a desk or on the floor or whatever, and you hit go, and it starts spinning around. The LiDAR, again, scans vertically, which I thought was counterintuitive at first, but it doesn't matter because you know how many degrees over it is because you're keeping track with the steps of the stepper motor, and you just stitch them back together. Really, really cool. The images are put together with the panorama stitching program Hugin, which I've used before. It's really, really nice. And then some clever math maps the pixels there to the point cloud off the LiDAR, and boom, you're done. A single scan takes kind of 10, 12, 15 seconds, depending on which LiDAR sensor you've used. And then stitching it all together and doing all the post-processing takes like 30 seconds. And he says if you want to turn it into a mesh for printing or whatever, you want to take the point cloud and triangularize or quadrilateralize it. That's something you should probably do on a real computer instead of on the poor little Raspberry Pi. But, that's why it's got Wi-Fi.
This brings up the perennial reminder of new components, that it's very easy to sort of know what components are out there and not notice that new and far better ones appear. It's like thermal sensors. You blink and the thermal sensors drop by another sort of factor of $10. And it seems to be the same with LiDAR sensors. Really interesting ones are coming down in price now, which can only be a good thing.
Yeah, really no joke. And actually, I looked at the sensors he was using here to try to get a feeling for how much this project was going to cost. And like I said, they're all easily under $100. The cheapest of them is like 60, 70, but it has such low resolution. The resolution on the most expensive of them, the STL27L, is absolutely phenomenal. And he does it in his backyard and he gets LiDAR imaging of the leaves on trees and things like that. So it's absolutely worth spending the extra $10 to get the really good LiDAR sensor here, I think.
It's been a trend over the last year for the PDA with a QWERTY keyboard, and often these are based around a powerful microcontroller, maybe one of the faster STMs or the ESP32 series, and they usually have some kind of operating system that can run a variety of different software. They're kind of replicating the PDA of old, normally with a few extras like emulators and other fun things for hackers. But there's one that caught my eye because it bridges the gap into cyberdeck territory. It's from Eric Jennett and it's called the Evertop. It's a really nice device with a full-size proper keyboard, a really quite large e-ink display. It uses silly low amounts of power and it's got a solar panel on the back. It's a laptop for people who go off the grid. Now, what caught my eye about it is that the software it runs a PC emulator. Now, by PC, I don't mean a sort of modern PC. I mean the original PC XT. But it's something that I'm surprised we haven't seen more of. There have been PC emulators around for quite a while now. The advantage of a PC emulator is that if it runs PC software, you've got instantly access to an enormous catalogue of software. And by today's standards, some of it may seem very, very clunky, and the sort of MDA DOS style interface is certainly nothing to write home about. But 30 or 40 years ago, these were the packages that we used every day and found really useful. And to be able to use that software library again on a very cheap microcontroller powered device actually makes it very, very powerful indeed, because it goes from being a hacker's toy into being a really useful computer. I'd almost go to the extent that I really do want to try building one of these. I know there are various options for doing it with cheaper displays and probably less fancy keyboards and stuff like that. But the idea of a DOS PC that uses almost no power and you carry everywhere is quite an interesting one. I'm not quite sure that there is a Jenny's Daily Drivers in there, because the whole point of Daily Drivers is, can I do my daily work? And the one thing, of course, it will miss is a modern full-featured web browser, which sadly, as a Hackaday writer, I need to be able to access Hackaday's website. But I'm beginning to realise that a DOS PC, there's a surprising amount you can still do on one. And it's all open source as well. Now with FreeDOS and an enormous amount of open source DOS software, you don't even have to pirate stuff. But you could argue that a lot of original 16-bit DOS software is abandonware anyway. There's certainly a very interesting project, this one. And it's a nice cyber deck, but the fact it's also a PC is an angle which I think bears more examination from other projects.
And it's super cool because the whole thing runs on, it's incredibly low power. It runs on an ESP32, and like you said, it has an e-ink display. So, you can get this thing hibernating fairly quickly, back up fairly quickly with a big old lithium-ion battery. He estimates in power saving mode between 200 and 500 hours. And that's not standby. That's, low power mode, but use mode. And then, of course, if you can put it in the sun for a little bit and recharge it, he's got a solar cell on there that will recharge the battery with, he says theoretically 1 amp in full sunlight, but has never seen it go higher than 700 milliamps. But given that the thing probably draws 70 milliamps, you're like way recharging the battery anytime you can get some sunlight on it. And given that it'll run for, however many weeks that was without even seeing the sun, that's really, really fun. I love the idea of just, kind of infinite computing resources in the sense of, an infinite amount of time of it. What's also fun is how many things he gets running on the ESP32. I mean, I guess this is kind of, it's an accumulation of everybody's hacker projects out there. But, he's got BASIC, he's got DOS, he's got a Windows emulator. It's got, he's got it playing Doom, of course.
Yes.
And, Doom on a slow refresh speed ink screen, it's nothing to write home about, but it's playing Doom. And so, congratulations on all of this. If you wanted to do some lightweight programming or simple text hacking around or, super retro gaming like he's doing here, Colossal Cave Adventure, it just seems like a really great idea. And it's relatively lightweight, relatively low cost, huge solar cell. Like, this is the sort of thing you'd want to bring on a camping trip where you still want to nerd out.
The question is, does it have a Hackaday reader?
Right? Yeah, you'd have to download that all before you left anyway, probably. Depending on how camping your camping is. Well, I love robots, and I love robots with strange grippers. And this week we got one from the University of San Diego. Go Tritons. Robot picks fruit and changes light bulbs with measuring tape. That, believe it or not, is not clickbait. This is a strange gripper. It looks like kind of the standard gripper with 2 wedges that close and open from each other, except the wedges are made by what looks for all the world like, just a spring steel measuring tape, but it's been rubberized, and they have motors on them so that they can angle in and out, and then they can retract. And so, how you can kind of bend the end of a measuring tape out, you kind of fold it over and you can kind of play with that. It's doing that, and those are the 2 fingers of this gripper. And so it can
angle. A very good idea.
Yeah, so it can kind of angle these triangles in on something, and then if they run at the same speed, it can pull the object toward it or push it away. And if the one side tape turns in the opposite side to the other, it can actually unscrew things. And so they have like a demo of it unscrewing a jar of pepper and then picking the jar up and dispensing it into a cup. I mean, simple stuff. But watch the video. This is a robot gripper of the like you have never seen. They call it grasping and rolling in plane, which of course gives you the horrible backronym GRIP. Yeah, they call it grip tape, which is a really cool, it's just a really cool hand. You haven't seen one like this before. It's a little bit compliant, of course, which I love compliant grippers. As long as you're not gripping it hard enough that the tape buckles, everything's cool. And so you've got a pretty good range of force you can apply on the thing. Yeah, it's a simple hack. It's a super clever hack, and I love to see, the humble tape measure reused in a robot design. And so before I leave, I'll throw in two more links to cool compliant slash squishy robot grippers. One is the fin gripper, the fin style gripper, which is usually made out of flexible plastic with a bunch of fins in between so you can grip onto things. Our write-up is called Compliant Robot Gripper Won't Scramble Your Eggs. This is from way back in 2013. Also from 2013, Dead Simple Jamming Gripper design. This is a jamming gripper made with a balloon, coffee grounds, duct tape, and a syringe. The video is particularly 2013. You should absolutely check it out. But the idea is evergreen. And so if you're interested in exploring some of the world of soft slash compliant grippers, you should check those out.
We're so used to 3D printers being essentially an open source device that we forget that makes them very much the exception to the rule. If you were, say, to compare them to laser printers or inkjet printers, which are universally closed source, it seems very odd that we expect a 3D printer to be open. And the reason 3D printers are open in this way is that about 20 years ago, we had the RepRap project. And the point of the RepRap project, it was to provide accessible open source 3D printing designs. But more to the point, the original sort of purist aim of the RepRap project was to have a 3D printer that could replicate itself. And to some extent they succeeded. So there were a lot of 3D printed parts, but they had to rely on so-called vitamins, which were all the nuts and bolts and screws and threaded pieces and whatever that you'd find in, I don't know, RepRap Mendel or something like that from quite a long time ago. Brian Minnick has managed to produce a 3D printer that can be 3D printed in its entirety. And it's a complete tour de force of the 3D printer's art. Now, it's probably best to make it clear, it's a working 3D printer, but it's probably not a 3D printer that you would want to use for yourself, because it's very much proof of concept and it's a 3D printer that works rather than something that can produce the kind of prints that you're used to getting from your conventional 3D printer. But it's what he's managed to do. He has 3D printed motors, for instance, working motors that are entirely 3D printed. The way he's done that is he's printed his coils using solder paste, which he then, of course, heats in an oven so that it melts together and makes the wire. I particularly like his hot end. His hot end is PEEK, which I can never remember the exact name, but it's a ether ketone polymer. It has an unusual property that it has one melting point if you just print it, but if you anneal it, the melting point goes way up. So you can actually make a hot end out of PEEK that will print PEEK if you anneal it. The control system is a very mechanical control system, which is yet again all 3D printed. And this thing actually works. As I say, I don't think that many people will print this printer as it is, but I do think techniques like using the solder paste to print conductive elements and things like the annealing, the PEEK, are very interesting techniques, which I'm certain that I will see used in other projects. And I really look forward to see what other people do with these ideas. This really is a truly awesome project, and I really mean that.
The vitamins have always been looked upon with scorn, by the righteous RepRappers, right? It's
Yes.
like, we'll do with the minimum we can. But then it's always been, but what about the motors? And the fact that Brian here is like, oh yeah, here, I'll 3D print the motors by melting solder paste to make the windings. Like, what? That's just so... Also, the way it's like programmed / run is also super mechanical, and it uses this, I guess, 3D printable data strip, which it then rolls over, and it's like one of those ancient looms that has the, a
Jacquard
physical...
loom.
Yeah, that has like a physical template for the print, but this is one that it can both print and can be 3D printed. This is taking the most strict version of the RepRap dream more seriously than I've ever seen anyone do it. certainly more seriously than it should be taken. But but what emerges from it is so cool.
Oh, very much so indeed. It has showcased techniques which I am certain we will see in other places.
My first quick hack comes from Shiura. It is a mechanical masterpiece. Printed perpetual calendar clock contains clever cams. Boy, what a title. And this one, it's true. Not only does it show you the time, the day of the year, it actually does that thing with the Februaries where they have leap years and keeps the time. So it's good. The only part that isn't 3D printed is the clock movement. So you plug in a normal clock movement and it turns that into the movement of the months, the days, everything else. It's going to be good until 2100. So print it now. Next up, the story of haircuts in space, how to keep your astronauts looking fresh. This includes video from the early 2000s up until today from both the ISS and the Chinese space station Tiangong. And the short answer is you basically need a Flowbee. You can't have hairs flying all around on the inside of your space station. You need to hook up the cutters to a vacuum cleaner. And here are some videos of astronauts getting ridiculous haircuts. And last and least, at least in terms of size, Vic Oliver's project, Jolly Rancher down to the micron. This is the story of his custom-built RepRap micron, and he calls this iteration Mouse. And here he is printing things with literally micron accuracy. It is outrageous. It uses a flexure mechanism, actually of Vic's own design, but very reminiscent of the open flexure microscope stage. And it has a print volume of 4 millimeters by 4 millimeters by 4 millimeters cubed. Scratching a Jolly Rancher 1.5 millimeters on a side onto a slide with some Sharpie on it. But then one of the most amazing things he does is to figure out a way to dip this super sharp electrochemically etched tip into some resin and deposit just the right amount on the substrate to actually make something that is going to be built up into the third dimension on this kind of almost micron resolution scale. He does a Triforce, of course, because, you can. It's easiest to write the G code for. So really, really cool. And I want to see where this one goes. I have never seen anything 3D printed this small, certainly not on a hobbyist level. And this machine is just exquisite.
Well, I've ended up with more quick hacks than Elliot this week. First up is Tommy with a very cheap, almost toy oscilloscopes with a sort of 100 kilohertz input bandwidth that you can pick up for not a lot from your favourite imported junk site. They are surprisingly capable for what they are, but they do have their limitations. And what he's done is give it a few upgrades, such as an input filter and some noise reduction to get the best out of its limited signal path. It's a kind of like a crash course in digital sampling. It's the sort of thing that you learn in your electronic engineering at university and come out with more of an idea of what's going on. Definitely, if I still had one of these little scopes, I did actually review one for Hackaday years ago, but I gave it away to somebody at my hackerspace. If I still had one of these little scopes, I'd probably be experimenting with it myself.
Funny you said university DSP because Tommy's actually a high school student, which makes this project an absolute standout in my book.
Well, that's pretty cool. I mean, good luck to him. I hope he goes far. The next one is Q Radio Link, who has an open source DMR radio. Now, that's digital mobile radio. Obviously, if you know any radio amateurs, you'll see them with a handheld. Certainly in times past, the handheld would have handheld walkie-talkie type radio, that is. The handheld would have probably been FM, probably on 2 meters. That's 144 megahertz or similar. Obviously, technology has moved on. We now have digital modes. There are several competing digital modes out there, but DMR seems to be the one that's gaining the most foothold. The trouble with DMR is it's always been proprietary. You've either had some quite expensive radios, some slightly less expensive radios from China, or that was it. And there are one or two projects out there trying to make open source DMR radios, and this is just one. I have to say, there's always a problem with these projects. They always require quite expensive SDR hardware, SDR transmitter hardware. So you're not going to be able to build one of these for pennies, but technology always delivers. So who knows, in a few years' time, perhaps you might be able to build one for a lot less than you can now. It's an interesting project anyway. Something that always seemed impossible when I was much younger, and then of course you started to see projects where people had done it, was building your own microcomputer from discrete parts. So making a processor from 7-4 logic chips or similar. It's now quite passé. A lot of people have done it. There are a lot of different designs, but it's still nice to see a new one. We have Dr. Matt Reagan, who has made, he's building a Commodore 64 entirely from individual 7-4 type logic and other individual chips. And he's made the 6502. It's interesting because, of course, he's not making the traditional building blocks that you would expect from, if you were to look at the manual for a 1970s processor, you would see the building blocks, the ALU and the registers and stuff like that. He's using an EEPROM, which is a sort of lookup table that does the job of the ALU, and a RAM chip, which stores all the registers, and obviously some glue to go with it. But it's a radically different design from how we would have approached it back in the day, but it does exactly the same job. And I rather like it because, well, it's not entirely a new thing. Things like the Gigatron, for instance, have done it for quite a while. It's still really cool to see somebody do it with something that you're very familiar with, such as a 6502. I look forward to seeing in the future how he produces all the other Commodore 64 chips. I'm particularly interested to see what he does to make a SID from First Principles, the audio chip. I'm sure we'll see more projects coming out of him on that one. And finally, we've got Phil Whip, or is that Phil work in progress, possibly, who has restored a rare 6-player arcade game from the early 90s. This caught my eye because back in the 90s, I worked in an adjacent industry. I worked in the CD-ROM industry. And at the time, the real potential of the computers that we have now was starting to show itself, but the hardware wasn't quite there. If you had an early consumer CD-ROM computer, you probably had a 386 or a 486 with a single speed or double speed CD-ROM drive, and it was probably particularly tedious to do anything. And to get anything impressive, you had to employ all sorts of tricks. So, for instance, you would have full motion video from a Laserdisc with your computer-generated character superimposed over it. And you got things like this crazy room-sized arcade game with 6 players. Each of them is basically a shooter. Each one has their own shooter. And I just liked it because of its ridiculous overuse of technology to get an effect that nowadays almost any cheap laptop could do without even breaking a sweat. We get so used to our computers being, by any measure of the word, supercomputers, that we forget just how far we've come. Maybe it's just a chance for me to wallow in the past, this one, but I liked it.
Well, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week, from me, Maya Pasha's Why Physical Media Deserve to Die. And boy, that is a little bit of a controversial title, and I don't think she's right, but we'll get into it anyway. I guess she starts with noticing the kind of resurgence of, is it nostalgia? Is it hipsterdom? People who are nonetheless collecting, despite the fact that it's 2025 and we live in the Jetsons' future, people are still collecting vinyl records and cassette tapes, 8-track tapes. We're looking forward to the mini disc revolution. But the question is, why are people doing this? And Maya kind of takes it apart with the, cold Spock-like rationality and decides that, all of these are inferior formats. And of course, that's not wrong. Like the signal-to-noise ratio on even a cassette running Dolby isn't as good as it is on the run-of-the-mill CD. And that's just about the same as high bitrate streamed audio. So, don't worry about it, folks. And ditto the VHS tape. I mean, if you think about the quality of video that comes off of a VHS versus basically anything these days, it's just absolutely horrible. audio cassettes, et cetera, et cetera. I mean, she also ends up by mentioning what killed physical media was kind of these streaming services, but now is some of the nostalgia for physical media due to the kind of fracturing hellscape that these streaming services are slowly turning into. Or maybe even just the realization that while streaming music is awesome because you have everything, it's only awesome as long as you pay their fee every month. And this is like setting you up for a lifetime of indentured servitude. You're going to have to pay them every month until you are in the grave to go back and listen to that music you wanted to listen to. I think that is the sense in which physical media shouldn't die. And I think a lot of people come into the comments to kind of express that opinion. Again, I don't know if I agree. I ripped all my CDs to a hard drive, let's say back in 2010. And I don't think I've played a CD ever since then. I don't think I have anything anymore on audio physical media that I don't have in a FLAC file at this point on my hard drive. And, so I may not be fully in the streaming camp, but, maybe I kind of agree with her on the physical media side, although it's nice to see a good album cover. What do you think, Jenny?
I may be slightly older than some Hackaday readers, it's fair to say. I grew up in the era when all these analog media were the thing to have. I did student radio when I was a student, and it was all 7-inch singles and 12-inch LPs, or 12-inch singles if you were lucky. There is some nostalgia for that time. I mean, I do have more than one vinyl record from back in the day. I certainly haven't bought any of the silly overpriced reissues for hipsters. I do own a turntable. To be honest, I very rarely use it. I haven't used a cassette in a very long time, I'm afraid, so I'm not quite going that far. What I will say is that there is an experience-based thing for me. So I am heavily into some analog media. I still take and develop my own chemical film. And in particular, I've done a lot of stuff with 8mm movie film. I never did that back in the day because it was too expensive. And of course, as a grown-up, I can now afford the occasional cartridge. And I got into it because I kept finding the cameras for virtually nothing in second-hand stores. And what I would say with that is you don't do Super 8 because you want a high definition video of the event. You do Super 8 because you want a record of the event that has the charm of a 1970s home movie. For instance, like if I go to a large hacker camp, I will usually take along a Super 8 cartridge or two, and I will shoot the event in 3 to 5 second bursts, and I will come away with a video that I don't even edit digitized from the film, which for me tells the story of the event, and that's the important part. Now, back in the day, people would almost like a sort of keepsake, a thing, you'd swap mixtapes. You'd make a mixtape for somebody, you'd make a mixtape for your girlfriend or whatever. And it was a personal thing. Here is not quite my radio show, but here is my selection of music. And of course, it's something that's completely gone. But if you have a connection with that particular sort of cultural thing, I can see why people do that kind of thing. I hasten to add, I haven't made a mixtape in probably about 30 years.
Yeah, right.
But I can see why people follow this. There's another angle, of course, the technology angle. Say, take the VHS video cassette. I know in great detail exactly how the VHS system works. And it really is a beautiful way of packing just enough to get watchable colour video onto less bandwidth than it should. There's certainly a lot of fun to be had from the tech side. Probably not enough fun for me to amass a large library of VHS cassettes, though.
Yeah, I mean, there's something that's just so approachable about cassette tape. Like, you can mess around with it, you can re-record it, you can cut it into loops and loop it. You can cut up a tape recorder, and you could break a tape recorder and turn it into an echo unit. It's all kind of more malleable simply because it's physical. And then as soon as I say that, I'm like, yeah, but how would you implement an echo in software? Oh, that's tremendously trivial. I could do that in 6 lines of Python, actually. So I take it back, right? Like it's a different, but there is something about the tactility of physical media and the different mode in which you can screw around with it. You don't have to think about, how many elements do I have in this array? And, what's my sample rate? And how long do I need to delay it so that it sounds like I'm King Tubby? Because King Tubby did it by just screwing around with cassette tape. And so, yeah, I don't know. I think there is something there about the tactility of it all. And a lot of people come up with that in the comments too. There's the DRM, which people also mention, although I don't think people are buying vinyl because they're pissed off about region coding on Blu-ray discs. I think they're buying vinyl because it's got pretty pictures and it's
Very
fun
much so.
and because it's fun to play records.
This has all reminded me of circa 1992 in University Radio Hull doing loops with the Revox reel-to-reel tape recorder on quarter-inch tape and having sort of loops hanging across the room and then sort of hooked over something. I don't know if anybody else ever did that, but certainly lots of fun to be had by all. But then again, I was the one who started the rot at that particular student radio station because, to my knowledge, I was the first person to bring in an Amiga and do editing in digital form in glorious 8-bit.
All right.
So I probably started the rot there. I must have a look somewhere in my backups. I may even have some of my reports and jingles and things from those days. I must actually go back and have a look.
You say something like Revox and it reminds me of old reel-to-reel tape recorders and how we had to clean the heads on them. And there's all sorts of maintenance and physical stuff that goes along with tape that's just completely unsavory relative to, just playing it back on a FLAC.
Happy days. Jumpers for goalposts, as we Brits say.
I have no idea what jumpers for goalposts means, but it's lovely.
It's something you would do in the playground. You're playing football. That's proper football. You're playing football and you don't have a goalpost, but you stack your jumpers up.
Right.
It's to invoke nostalgia. Well, after our media explosion, it's a tough act to follow, but I have Dan Maloney's piece about the history of X-ray detection. We all know that X-rays are dangerous, and we've all seen the X-rays of Mrs. Röntgen's hand with the wedding ring, I believe, and we've all heard about, I think it was Thomas Edison's assistant who ended up getting some dreadful cancer in his hands because he'd had so much radiation. Probably a lot of the history of the last sort of 100 plus years of X-ray imaging has been about doing it in a more safe manner, using less X-rays, detecting them more efficiently and with less noise. And Dan has written a fascinating rundown of that process. Starts talking about film and scintillators and photomultiplier tubes, and he mentions the lethal things that apparently were in shoe shops where you could see how well your children's feet fit in the shoes. I'm sadly not old enough to have ever seen one of those myself. They certainly had disappeared from the UK by the 1970s, but I've certainly had those things described by my parents, and I'd have been fascinated to see one myself, even though I'd have probably gained a lifetime's exposure to ionizing radiation as a result. Probably the most interesting part of that thing comes at the end, though, talking about the digital sensors, because I understand how a scintillation screen works. I understand how film works. I understand how a photomultiplier tube works and all the other techniques. But the digital sensors, I just see the radiologist turns up with a sort of big plastic thing which he sticks underneath whichever unfortunate part of you is just injured. I'm thinking if I had a parkour accident where I bashed my elbow, they did this. But you can't exactly say when you're in the hospital's diagnostic centre, excuse me, can I take that part and see how it works? And so having somebody explain how it worked was really interesting. If anybody wants to do a teardown and stick it up, I'd love to see that on Hackaday because I'd love to see inside one of the things. But I strongly suspect they cost rather a lot of money, so the chances of finding one for a teardown are not high. Anyway, what do you think, Elliot?
I didn't actually know about the scintillation layer. So basically in the super early days, they would just hit enough X-rays onto the film that the film would be exposed directly. But that's a hell of a dose. And instead you can paint a plastic layer with something that glows when it gets hit by X-rays. And so you get a whole crap ton of photons off for every X-ray, and this cut the doses down by like factor of 100, factor of 200, and made X-rays ridiculously safer in comparison. Which is where you get those fluoroscopes from in the shoe store, right? Because they were passing what they thought at the time was so little X-rays through your feet. They could just do it for the heck of it at that point. I guess I'd never thought of it really hard, so it was just nice for me to read about that. And, the old trade-offs between whether you use 2 fluorescent layers, one on either side of the film. Of course, there's more light splatter if you do it that way. So you get a little fuzzier picture, but you get to use half the radiation you would otherwise for the same exposure, et cetera, et cetera. There's just all sorts of fun little details about X-raying here that I had no idea of. And in the end, you mentioned that nowadays everything is just direct sensors, and it's just like a CCD sensor. It's a CCD that's tuned up for X-rays, and that's the whole game. I feel like this is giving me flashbacks of our physical media article that we just talked about. I pine for the crazy scintillation layers. This is straight to digital, bam into CCD. There's no refinement there. There's no trickery. It's just like read the X-rays where they land.
Funnily enough, this week I've been thinking about one of these technologies in another context. I've been researching Polaroid cameras for a different piece I'm working on, and I found that there were a whole load of Polaroid cameras specifically for dental X-rays. And I actually remember my dentist when I was much younger had one of these things, and it's just a hazy memory because stupidly I was probably more interested in the gears that powered the drill or whatever he had than actually looking at the camera he was holding. I'd never thought I'd actually want to remember it 40 years later. I do remember it was the thing where they had to wait and then peel it apart, like on the much older Polaroid pack film cameras.
Exactly. I wonder if you could find these old, like the last generation of scintillation plus digital detectors for cheap these days on eBay, because that was kind of the 90s when those got phased out. So maybe I need an X-ray machine like I need mutations on my chromosomes, but it'd be hella cool to have one.
Do not look into X-ray with remaining eye.
Yeah, exactly. That wraps it up for this week's Hagaday podcast. Thank you very much for listening. To follow the links, head on over to hagaday.com/podcast. And if you see anything that you'd like us to write up, shoot us a line, tips@hagaday.com. And until next week,
eat, sleep, hack, repeat. The legendary DJ terminal.
Which is... whose project is this? Why don't I have the name? Why did this...
The hacker with no name. I would call it a tape measure in British English, certainly.
It is called a tape measure. Okay, fine.
The spring steel ones, yes?
Can I get you to say P-E-E-K a couple times?
P-E-E-T. I call PLA rather than PLA.
Pla.